Hey folks, how's it going? We've got our last video here. Please try not to get emotional as we work our way through this, but I'm sure we can make through it and get through this together. But anyways, Wakanda forever. Let's get started. I recommend that you pull out a ruler or a straight edge while we're doing this, for the first thing we're going to do, I actually want you to give this warm-up a try. Just go ahead and get your hands over here and, place them over the warm-up. Get nice and toasty. Warm up your hands a little bit. Warm up your brain. See if you can do these three problems. Okay, how did it go? Did it go well? I'm sure it did. Okay, hopefully this isn't too bad. They want arc AD and BC. Arc AD is over here. It's intercepted by this inscribed angle. So if this is 70, then that means this arc is going to be 140, 2 times the inscribed angle. And then arc BC, which is over here, that's intercepted by this angle, angle A. And if angle A is 30, the arc that it intercepts is going to be twice that, so that's going to be 60. And then let's go over here to angle 1. Number 2 says they want angle 1. Well, we see this little triangle over here. This angle's 30 and 70. By the triangle sum theorem, that means this little angle in here is going to be 80 degrees. That's this angle. And this angle is a linear pair with angle 1. So that means angle 1 is going to be 100 degrees. Now, do you notice any relationship here? This is 100. 140 plus 60 is 200. Oh, and this is what? Half of that. Interesting. Let's see if that comes up again later, shall we? Well, let's slide on down to secant lines. Let's do a quick definition of what a secant line is. Really, all you need to do is start by drawing a line through a circle. And this is a secant line. It intersects the circle in 2 points. So let's just kind of write that down. Secant line intersects a circle in 2 points. And let me call this point A, I'll call that B. And we would say that line AB, notice the arrows, line AB is a secant line. Oops. Sorry about that. Whereas segment AB is a chord. So chords are just pieces of secants. And now I wanted to talk about how lines can intersect circles. There's a bunch of different ways down here. First of all, two lines can intersect circles on the circle. So like this. Yeah, and that's 2 secants. Or 2 lines could intersect on a circle like this, where you have a tangent and a secant. So that's 1 tangent, 1 secant. Slide up a little more. And then there's only one way 2 lines can intersect in a circle. It's just if they're 2 secants. 2 secants. You notice I haven't talked about 2 tangents intersecting over here, right? Because 2 tangents couldn't intersect on a circle. 2 tangents couldn't intersect in a circle. However, 2 tangents could intersect outside of a circle. And we've seen this scenario like that. Right? Outside of the circle, you could have 2 tangents. Feeling I'm going to run out of space, but we'll see. Or you could have two secants intersect outside of a circle, right? That's two secants. Or you could have one tangent and one secant intersect outside of a circle. So again, that last one is one tangent, one secant. And we're going to see, we're going to get into a little more detail for each of these scenarios in different ways, and you'll see how we play with that. So let's flip over to the next page, and let's go to angles. So we're going to look at some of those intersecting lines in the circles and see how what angles are formed and how we can describe the measurements of those angles. First of all, let's start with two secants intersecting in a circle. So that might look something like this. I don't know, like that. I intentionally didn't have them go through the center, but technically it would still work even if it went through the center. But I just wanted you to see that that doesn't have to be the case. So this scenario has angles formed by two secants intersecting in a circle. And so let's call this angle in here angle 1. And let's call the measure of this arc out here x. Now notice this is not a central angle, and it is not an inscribed angle. That's important that we realize that. An inscribed angle would be on the circle, a central angle would be on the center. So this is neither of those. So we don't really have anything nice to solve this except this method right here. And then this arc over here would be y. So if you notice, this is kind of reminiscent of the warm-up problem, right? So, and what's the relationship in the warm-up? Hopefully, again, you notice that this was half. So, measure of angle 1 is actually equal to 1/2 of x plus y. 1/2 the measure of the sum of these. You add these arcs together, cut them in half, or divide that by 2, and that's what angle 1 will be. Pretty cool, right? And if you're curious about the proof for this, I won't do the proof for this, but it's related to, like, if you drew a little line in here, you could figure out the proof accordingly and see, like, this angle is 1/2 of arc y, this angle is 1/2 of arc x, etc. Again, I'm not going to go into detail on that. But let's continue on through this page where we've got 3 more scenarios to deal with. There's one scenario, let me slide up, with two secants intersecting outside of the circle. So yeah, so now we're moving outside of the circle. Excuse me. So this, you might be wondering, oh wait, why did we skip on the circle? Why did we skip this? Well, we actually didn't skip this. We talked about these situations with inscribed angles, right? So now we're going to talk about angles when lines intersect inside and outside. So let's say we've got, let's call this angle 1. I'm talking about this angle in here. That's angle 1. Let's say that the measure of this arc is going to be x, and the measure of this arc is going to be y. And what's the measure of angle 1? You know, there's a number that's going to show up a lot today, and that number, especially with these angles, that number is 1/2, because 1/2 shows up here again. And it's actually, this time, up here we added up the angles, but now we moved outside the circle, and I added the angles, technically the arcs. Now we're outside of the circle, and we're going to subtract the arcs. So here it's x minus y. So this outer arc minus the inner arc divide that by 2, then you'll get the measure of angle 1. So next, the next scenario is a tangent and a secant. We'll have angle 1 again. Here's the point of tangency. This arc, let's call that, I don't know, y. And this arc, what should we call it? Oh, let's call it x. Great idea. And guess what, folks? Measure of angle 1 is again 1/2 times x minus y. This outer arc minus this inner arc times 1/2. The same deal. Pretty cool, right? And by the way, again, I'm not going to go into the proofs, but here you could prove it just by drawing this line, looking at these angles, how they're half of these arcs, this is half of that arc, and then relating it to this angle. Notice there's a triangle here. If you want to think about it on your own, please. I can't think of a better way to spend an evening than thinking about proofs. So, let's deal with one more scenario, and that's with two tangents. So again, we're talking about angles here. Say we've got two tangents. Yeah, something like that. And again, let's call this angle 1. Now this is, and then here's a point of tangency, here's a point of tangency. You have to be a little careful here. We're going to again have our two arcs. This arc, let's call it, x. And then this arc over here, we'll call that y. So, just be careful. It's true that x plus y equals 360. So that's an interesting thing to note. But here the equation is going to be totally different. It's something that's, oh my gosh, it's nothing like, wait, no, I'm just kidding. It's exactly the same. Oops. Oh man, this whole time I was out of range. Sorry about that. So again, let me just back up. Sorry about that. Two tangent lines. Here's the point of tangency. We call this x, and then this y. X plus y, yes, it does equal 360. That's basically the whole circle. And then the equation is going to be the same. The formula is the same for all three scenarios. Okay? And cool. All right, I'll see you in the next video.